Welcome to qnawire.
We'll be looking at friction and screw. Consider the problem where we need to determine the compressive force developed in a vice clamping an object. Uh, since we are talking about clamping, to solve this problem, we need to determine what relevant equation, the appropriate equation to use, and plug in our parameters to solve the problem. So that for these ones, this clamping, I'm going to use M, the moment, is equal to arrow, which is the main radius of the screw, P, the force we are talking about that we want to find, and tan of theta, which is the lead angle, plus the angle of static friction, phi. Right? Now, we know that the arrow is already given at 0.006, and the lead L is given as 0.008 in all in meters. Okay, we can look for our lead angle from here, which is equal to the arctan of the lead over 2 pi arrow. You plug it in everything there, you're going to arrive at 11.98 degrees. You can as well look for the angle of static friction, which is the arctan of mu. Mu is given, which is the coefficient of static friction. So 0.27, when you plug it in there, you're going to arrive at 15.1 degrees. Okay. Then the next thing, you can make P the surrogate of the formula, the force that we are looking for, so that it becomes equal to M, the moment, over R tan phi, tan theta. You've already gotten this angle, the angles already, plus phi. Okay. So you can look for your M. M is equal to the force, the couple force is given in the question, times the perpendicular distance, which is also given. The perpendicular distance is given as 0.25. So the couple force is 35, okay, and perpendicular distance is 0.225 meters. The couple force is in Newton, 35 Newton, okay? This is in Newton. It's given in the question. This is in newtons, while this one is in meters. Okay, this is in meters. Okay, when you plug them into the equation, you are going to have, so we can just remove this one, plug them into the equation, you're going to arrive at your P to be equal to 35 times 0.25 over 0.006, okay, tan 11.98 plus 15.1. Okay, so when you do that, you're going to arrive at 2000. Just plug in all the, you're going to arrive at 2,850.2 Newton. Okay, which is also the same thing as equal to 2.85 KIP. So that is the compressive force. So this